Yeah, good evening. I'll sharing my screen.
Good
Last
evening.
class, we seen about the basic, the RTL design. Okay, this is RTL design, and we see in the device and design flow what is Verilog, HTL. Okay, what is the difference between like high level language and hardware descriptive language, features of HTL, and abstraction level, different types of abstractions we see in circuit level, gate level, data flow level, and behavioral level. Okay, so what is the circuit level and gate level, and RTL register transfer level means the data flow level and behavioral level. This is the program structure we see in. Okay, program structure. Circuit level means a basic. This is the low level design. That means we are designing for CMOS circuits. Okay, and data flow gate level means we need to use some gate level primitives. Okay, so that this is the syntax for gate level modeling. And register transfer level means we need to write the program for simple half adder, so we can write by using this data flow modeling, that is by using expressions, and behavioral modeling, that is by using case statements or if else statement or while statement. And so till here, any doubts or any queries? Shall I move forward? Do you
Oh,
have
sir.
any
Yes,
doubts or
sir.
any queries? Okay. So next we'll see lexical tokens and keywords, and mainly we'll discuss the operators. Okay, what are these operators? We'll discuss. Okay, data types we'll see tomorrow. So lexical tokens are nothing but a Verilog file is a stream of lexical tokens. Okay, typical lexical tokens are like white space. Okay, so white space shall contain the character for space, tabs, and new lines. Okay, so these are the white space, and that means here when you are writing any code, so that will be start with the comments. Okay, so comments are like single line comments and multiple line comments. Single line comments are indicated like this. Single line comments are indicated like this. Okay, these are single line comments. Multiple line comments are, that means it will be like so ash star, and this is multiple line comment, and star ash. Okay, this is multiple line comment. Okay, and nesting of comments is not allowed. That means comments under comments is not allowed. Okay, so nesting of comments means what? Suppose if you are writing like slash star, and this is multiple comments, again star slash, again comment under comment, comment under comment, it is not allowed. Okay, nesting of comments is not allowed. And identifiers, so identifiers means suppose like I told you, no, so any program will start with what, so any program will start with we see in the program structure. Okay, so module and module name. Okay, this module name is nothing but identifier. Module name is nothing but identifier. Okay, so there are some valid identifiers and invalid identifiers. Okay, so that those are nothing but, suppose here you see, so module, and what is my module name? Half underscore adder data flow. Okay, here you see module half underscore behavioral. Okay, so this is nothing but my identifier or module name, we can call as module name. Okay, so what are these modules? Are nothing but, see here, one second, this one identifier. Okay, so the identifier can't start with the dollar. Okay, can't start with dollar, or can't start with the 0 or 9. That means can't start with numbers. Suppose here I am writing, suppose half adder is there, it should not start with the this dollar half adder, or it should not start with the number 1 HA. Okay, or like HA it will take. Okay, H underscore A it will take, H underscore capital A it will take. Okay, H space A it will not take, H space A. Okay, like this the compiler will not take. Okay, so that means simple identifier shall be any sequence letters, that is dollar can be, you can like you can include suppose if you are writing for 2 cross 1 marks. Okay, so 2 cross 1 marks means your module name is module. What is my module name? So if it is number means the identifier will not take. So how it will take means underscore 2 cross 1 marks. Now it will take, it can start with underscore. Okay, the compiler will take. Okay, so that means error underscore condition, this is also it will take underscore bus 3 or n dollar. That dollar can come between the letters and numbers, it will take. Okay, so these are nothing but valid identifier or valid identifiers. Invalid identifiers are nothing but it should not start with this dollar or number, or it should not have the space between this H and A and H. They should be not having any space like that. Okay, so these are nothing but valid identifiers. Okay, escape identifiers are nothing but it will be start with this backslash. These are nothing but escape identifiers. Okay, with white space. Okay, these are nothing but we call as escape identifiers. Okay, uh, coming to the keywords. Okay, I told you, like I showed in the Google also. So that means the keywords are nothing but predefined or non-escape identifiers. So we need to include these keywords. Okay, and all keywords should be so this Verilog code is a case sensitive. Okay, so Verilog code is case sensitive. So it will be start with module, input, output, initial, always, begin, end, while, end module. These all are nothing but we call as keywords. Okay, so yesterday I showed the keywords. No, these all are nothing but keywords. Okay, so we can't include the variables with these keywords. Okay, and coming to the value set, it will support 4 sets of value set. That is nothing but 0, that is nothing but false condition, logic 1, that is true condition, and unknown is nothing but either it may be 0 or 1. This is unknown. Okay, and high impedance is nothing but suppose in the analog or electronics also you studied, so MOSFET have high impedance is nothing but two wires are like open, two wires are like open. This is nothing but we call as high impedance. Okay, unknown means we already studied in the digital, that is don't care. The don't care values are either 0 or 1. Okay, and next, number specifier. So how the number is specified means this is the syntax. Okay, so that means here it can be the number can be decimal, hexadecimal, octal, or binary. Okay, so like size, tick, base format, number. Okay, so this is the number format. Okay, size, tick, base format, number. Okay, size is nothing but by default the compiler will take 32-bit of size. Okay, size is 32-bit of size, and base is nothing but if it is binary you need to include with B, if it is octal you need to include with O, and if it is decimal you need to include with D, and if it is hexadecimal you need to include with H. Okay, so this is nothing but base. We already seen in the number systems in the digital number system, same that like that. And number is nothing but my integer value. Okay, suppose like you given 5. Okay, you not specified any size or base format. By default it will take as which number means the compiler will take as decimal. Compiler will take as what? Decimal. Okay, so internally it will store in terms of 32-bit. 32-bit means what? So this underscore is nothing but for readability purpose you are separating 4 bits. Okay, for readable purpose you are separating the 4 bits. So all are 0 only. These 4 bits are 0 1 0. Okay, suppose 2 tick binary 3 is there. So internally how it will store means it will be stored in terms of binary only. So this is how much size? 2 size. So what is the binary representation for 3? 1 1. Like this it will store. Okay, and 2 tick hexadecimal A6F. A6F means what? A is in hexadecimal A is nothing but 1010. Okay, so 1010. 6 is nothing but what? 0110, and F is nothing but 1111. Okay, so like this it will store. Okay, 8 tick octal 576. So this is O is nothing but octal. So octal means you converted octal to binary, no? So octal to binary means each and every bit you need to represent with 3 bits. Okay, so that is 5 7 2. Okay, so this is 0 1 0 1 1 1, and how many bits? This is 8 tick. Size is 8 tick, no? Size is 8 means already 6 are completed. So it will be represented with 0 1. Normally 1 you will get, but the size is only 8 bit. It is represented like this. Okay, and suppose Suppose minus 8 tick d5 is there. Okay, so minus 8 tick d5 means how it will store, anyone say how it will store? Suppose if you are giving negative value, how it will store, anyone? Hello.
Two's complement.
Yes, it will be stored in terms of 2's complement. Okay, so what is the reason for storing the 2's complement? Can anyone say what is the reason for?
Addition is simple. Addition is means simple. We need not to convert it in any other
Not
format.
that,
We can
not that,
simply.
not, no, there is not answer. I'm expecting that who the those I taught digital. I'm expecting from them. Those I taught digital. When we discussed the negative number representation, there are three representations. No, I'm expecting answer from them. There I told. Anyone? No answer. For whom I taught the digital, I'm expecting the answers from them. Okay, I think you're not gone with the digital. Actually, like the negative numbers are represented in how many forms? Sign magnitude, one's complement, and two's complement. Okay, somebody unmuted. Can you say somebody unmuted? Okay, I will tell you.
I didn't get your question, sir.
Actually, like normally, if you are giving negative numbers, okay, in the computer or it may be Verilog or system Verilog, any C programming language, yeah, so the answer came. That means it is represented in two's complement form. So my question is, why it is not representing in one's complement or sign magnitude? Why only it is representing in two's complement? Did you understood my question?
Yes, sir.
Any answer? This is also one interview question they can ask. Okay, orally they can ask, in the digital also they can ask. I told you in the negative number representation, that is sign magnitude, one's complement, and two's complement. Okay, so in sign magnitude and one's complement, for minus 0 and plus 0, two representations are there. For sign magnitude and one's complement, two representations are there. Okay, so that means two representation for plus 0 and minus 0 means if you want to store 0 value, the compiler will not understand to store minus 0 or plus 0. Okay, but coming to the two's complement form, for minus 0 and plus 0, only one representation is there. Only one representation is there. That's why whether when you are giving the negative number to any computer or any programming language like Verilog or C language or C++ or system Verilog, it will store in terms of two's complement. Okay, so here how it will store, like 8 tick binary. So 8 tick, this is decimal, no, decimal 5 means minus 8 tick decimal 5 means first 5 you write in terms of 4 bits, 0 1 0 1. Okay, so apply one's complement and convert into, one second, sorry, this is one's complement, and adding 1 to this, what you are getting, 1 1 0 1 1 1 1 1. Okay, so this will be stored in like this will be stored like this. Okay, so triple one triple 4 ones 1 0 1 1. Okay, it will be stored in terms of two's complement form. Okay, understood how why it is storing in two's complement? Why? Because only one representation for 0, whereas in sign magnitude or one's complement, two representations for 0. Do you understood? Any doubts or queries? Shall I move forward?
Yes, sir.
Okay. So coming to the operators, we'll see the operators. So operators are nothing but in the programming you are using these operators. Okay, so this one is concatenation operator. This is for combining the operators, and next is this is replication operator. Okay, and next is you have some unary operators also. So unary operators are nothing but you are using only one operand. Okay, and arithmetic operators are plus, minus. Plus minus operators, you know, for addition, subtraction. Star is for multiplication, and forward slash is for what we call division. You get quotient, and double star is for power. Okay, power, getting the power. Okay, and modulus is for getting the remainder, getting the remainder. Okay, and greater than or equal to, less than or equal to, these are relational operators. Okay, and next logical operators, you have three operators are there: logical negation, logical and, logical or operations are there. Okay, and logical equality, inequality is there. Okay, and case equality, case inequality is there. And bitwise operators are bitwise not, that is bitwise negation, and bitwise and, bitwise or, inclusive or, bitwise exclusive or, and bitwise equivalency is nothing but XNOR. XNOR is also called as equivalency gate. No, in the comparator, you got A equal to B is nothing but XNOR gate you got. Okay, so that is this is two symbols are there: cap of not gate or not gate cap. Okay, not gate cap. Okay, these are the two symbols for bitwise XNOR operators. And you have reduction operators: reduction and, reduction or, reduction nor, reduction XOR, reduction XNOR. Okay, two symbols are there. And you have shift operators. This is nothing but logical shift, and arithmetic shift left, and this is we call as a conditional operator, or we can call as ternary operator. Ternary operator means three operands will be there. That is nothing but ternary operator. Okay, so each and everything we'll discuss in detail. Did you understood the operators? You respond so that I will move forward. Hello. Yeah, did you understood operators? Hello. Shall I
Sir.
move forward? So we'll discuss in
Yes,
Sir,
sir.
detail. Okay, about
Bitwise,
this in detail we'll discuss. Okay, don't worry. We'll discuss today.
sir,
We'll discuss operators only. Okay. After that we'll go to the next data types. Okay.
sir, I have a doubt.
Yeah, yeah. Tell me.
Sir, bitwise operators and reduction and both are symbols are same, no, sir.
Both are symbols are same only, but here reduction operators means I will tell you. Here you have like one operand is there, one operand. Suppose bitwise operators means it will do like suppose bitwise operators means I will tell you. After that your doubt will be clear. Okay, I will explain. In clear in detail. Okay, so that your doubt will clear. Okay, first we'll see about logical operator. First we'll see about the logical operator. So in the logical operator, what are there? So after completing this operators, your doubt will clear. Okay, so logical operator. So what are logical operators? What are logical operators? Okay, logical and, logical and logical or, and next logical not. Okay, what are the symbols? Double ampersand. Okay, this is two slashes, and this is the symbol for logical not. Okay, so the value of logical operator are either false condition, true condition, or don't care. Okay, false condition, true condition, or don't care. Okay, so we'll see some example. Suppose the data types I will tell you: reg 1 down to 0. 1 down to 0 means how many bits? This is 2 bits. Okay, and reg let us take 1 down to 0, 1 down to 0 b. Okay, 1 down to 0 b. Okay, so A equal to 2 tick binary 0 1 and B equal to 2 tick binary let us take 0 0. Okay, so if it is a non-zero value, the value it will take as 1 only, true condition. If it is 0 value, the value it will take as false condition in logical operator. Any non-zero value you take, it will take the whole value as 1 only. Okay, so here you am taking A equal to logical AND of B. So A equal to logical AND of B means what? X equal to 1 logical AND of 0. So what is the value of X? So X equal to what? 0. Okay, if I display, this is system task, dollar display the value of X is percentage b comma uh, percentage b comma x. Okay, when you execute this, you will get the value of x equal to 0. Okay, similarly, suppose if you take the same values, suppose if I take y equal to a logical r of b, a logical r of b. So a logical r of b means what? So a equal to what? 1 logical r of 0. Logical r of 0 means so here you are getting y equal to what? 1 or 0 means what? Any one of the input is high, the output is high. So you are getting y equal to high, like that. Okay, so it will show like suppose z equal to logical not of let us take a. Okay, that implies z equal to what? Logical not of what is a? 1. Okay, so logical not of z, so z equal to what? You will get 0. Did you understood the logical operator how I am doing? Hello.
Yes, sir.
Okay, suppose if you take one more case, let us take a equal to 2 tick binary 1x, 2 tick binary 1x, and b equal to 2 tick binary 0 0. Okay, so it will take as what? X, no? 1x means what? Any values don't care, it will take as don't care only. So what are the values for the logical operator? 0 1 and don't care. Okay, so here it will take don't care, and here it will take what value? 0. The whole value it will take as 0. Okay, suppose if I write x equal to a logical AND of b. Okay, a logical AND of b means what? X logical AND of 0. Okay, so 0 logical AND of 0 means what? You are getting 0 only. Okay, and 1 logical AND of 0 means what? You are getting 0 only. What are the possible conditions for 0 x? Either 0 or 1, no? That I took. Okay, so that means you are getting 0 only. X value equal to what? 0 only. Okay, suppose I am taking y equal to logical r of b. A logical r of b means what? A logical r of b means don't this is don't care logical r of 0. Okay, so here also you will get 0 logical r of 0, you are getting 0. 1 logical r of 0, you are getting 1. What is the value of y? Tell me.
Y is
Don't care.
equals to x.
X, y equal to x.
Don't care.
Don't care. Y equal to x. Why? Because compiler. So here you are getting at one stage you are getting 0. At second stage you are getting 1. So that means compiler can't means it will throw the don't care. It will throw the don't care. Okay, this is nothing but logical. Okay, just we will see one program related to this. 1 second, I am opening this in the Xilinx Vivado so that it will be clear. Programs logical operator bitwise operator. It's Xilinx Vivado is opening. here logical and okay. So this is my program, okay, just copying this, and here I am pasting, okay. See this one, so that means here what I did, so that means module logical and this is reg 2 down to 0. This reg 2 down to 0 means this size is how many bit, means 3 bits. 2 down to 0 means 3 bits, okay. And reg xyz is nothing but this data types I will tell you, don't worry. Initial begin reg xyz is nothing but this is 1 bit, okay. So reg is by default this is 1 bit, okay. A equal to 5 means a equal to 5, so a equal to 5 means it will store like that means it will store like what, this is how many bit, 3 bit, no. So it will store like 101, 3 bit means 101, okay. And b equal to what, directly he given 111, okay. And c equal to what, c equal to tick means I not indicated the size. By default what is the size, 2 down to 0, no. So 2 down to 0 means this is xxx, okay. So logical AND operation means so if you see, this will take as true condition, this will take as true condition, and this will take as don't care condition, okay. So x equal to what, a logical AND of b. A logical AND of b means what, 1 logical AND of 1. So what is the value of x, x equal to 1, okay. And y equal to what, a logical AND of c. So a logical AND of c is nothing but what is a, 1 logical AND of c. What is a, what is c? C is x, no. So x means 1 logical AND of 0 means you are getting 0. 1 logical AND of 1 you are getting 1. So that means what is the value of y, y equal to x you are getting, okay. And z equal to what, b is 1, so b and logical AND of 0. So that means here 1 logical AND of 0, okay. This is z equal to you are getting 0, okay. So this we will see in the Xilinx Vivado where I am getting the same outputs or not. So here whatever the program you are writing, that go to the simulation. Here I wrote some sample programs. So whatever the program you are simulating, that you need to right click and set as stop, okay. You need to right click and set as stop, okay. And you will get 3 lines, that is nothing but set as stop, okay. Run the simulation, run behavioral simulation, run the simulation and run behavioral simulation, so that you can see the output in TCL console, okay. Yeah, see here the value of x is what, 1, y is x, and z equal to 0. You got the output or not, okay. Value of x is 1 and y is z and z is 0, okay. So you got the output, okay. Yeah, any doubts? Suppose if it is logical OR, okay. If it is logical OR, what you need to do, same value, same program you take. So that means x equal to what, 1 logical OR of 1. So what you are getting, x equal to 1, okay. Y equal to what, 1 logical OR of x, okay. So 1 logical OR of 0 means 1 only. 1 logical OR of 1 means what you are getting, 1 only. So y equal to what, 1, okay. Z equal to what, 1 logical OR of 0. So this is equal to what, z equal to 1 only you are getting, okay. All values you are getting 1 only, okay. That I am seeing in the Xilinx Vivado. So close this simulation, So I am simulating which one, go to the simulation sources, and which one logical, one second, I need to do logical OR, no. So right click, set as stop, that is setting as stop module, and run as a simulation. See the output in TCL console. Yeah, so the output here you get, see here the value of x is what, 1, value of y is 1, and z is 1, okay. So here I am displaying this, that is nothing but this is system task, $display in the double quotes the value of x is %b. %b is nothing but format specifier. So that means if you are If you are including D means it will display in terms of decimal. If you are including O means it will display in terms of octal. If you are including H means it will display in terms of hexadecimal. Here binary, B means what? Binary. This is nothing but format specifier. Okay, so Y is percentage B, Z is percentage B, double quotes close, comma X comma Y comma Z. Okay, so this is actually system task. Some system task will be there that we will discuss. Dollar display is nothing but same as what we call in the C language you have printf, no? Same like that you have dollar display in the Verilog code. Okay, dollar display is the system task, and bitwise not also. See here, bitwise not means that means not of A, not of B. Here, if suppose if I consider here not of A is there. Okay, not bitwise, logical not, no? So logical not means what? Logical not means not of A, that is equal to what? 0. Not of B, that is equal to 0 only. Not of C, that is equal to what you are getting? X. Okay, that is nothing but logical not operation. Okay, so logical not operation, if you see where logical not, okay, this is logical not. Okay, set as stop, set as stop, and run the simulation, run behavioral simulation. Yeah, see here, the value of X is what? 0, the value of Y is 0, and Z is X. Okay, you got the output, no? Yeah, did you understood the logical operators? Any doubts or queries? I will keep my charging. 1 second. Anyone give response? Any doubts or queries?
No, sir.
No, sir.
Okay. So next we will go with 1 second. Yeah. So next we will go with bitwise operator. Okay, what are these bitwise operators? Okay, so in the bitwise operators you have bitwise operators. So in the bitwise operators, you have bitwise and, okay, only one ampersand is there. Their logical means double ampersand is there. Okay, and next you have bitwise or, and next bitwise XOR. XOR is nothing but cap. Bitwise XOR cap. Okay, and next bitwise XNOR. Two symbols are there, not of cap or cap of not. Okay, and negation, bitwise not, negation or bitwise not. So this symbol. Okay, so what are these bitwise operators means? Suppose you take reg 1 down to 0 A comma B. Okay, this is 2 bits, and reg 1 down to 0, let us take C. Okay, so initial, okay, C equal to what? C equal to A and B. Okay, I am doing bitwise operator. So let us take A equal to 2 tick binary 1 0, B equal to 2 tick binary 1 1. Okay, so what it will do? Bitwise operation it will do. So that is 1 0 1 1. So bitwise AND operation it will do. So that means this is nothing but 0 you will get, here you will get 1. So that means C equal to what you will get? 1 0 you will get. Okay, bitwise and same values I will take. So A equal to what? A equal to 2 tick binary 1 0, and B equal to 2 tick binary 1 1. Okay, if it is bitwise OR operation, so what I will do? C equal to A bitwise OR operator. This is a bitwise OR operator. Okay, so a bitwise OR operator means 1 0, it will do the OR operation. Bitwise OR operation it will do. Okay, so this is nothing but bitwise OR means bitwise OR operation. 0 or 1 means what? 1, and 1 or 1 is equal to 1. So at last you will get C equal to what? 1 1 you will get. Okay, 1 1 you will get. Similarly XR also, bitwise XR, so you can write A equal to A cap of B. Okay, A cap of B, bitwise XR, and so this is 1 0 and this is 1 1. Okay, so XR operation, so XR operation means this is 1 and 1, C equal to 1 1 you will get. Okay, and XNOR means what? XNOR means here not of cap, no, so that means C equal to A not of cap B. Okay, so 1 0 not of cap, bitwise NOR operation, not of cap 1 0. So here 1 1, this is 1 1. So 0 1 means what? 0 1 means you are getting 0, 1 1 means 1 you are getting. C equal to 1 0 you will get. Okay, I think here you will get 0, no, both inputs are same, just complement you will get. Okay, not means what? Suppose A equal to what you took 1 0, no, so not of A, not of A equal to what? 0 1 you will get. This is nothing but bitwise not. Okay, so this is about the bitwise operators. Bitwise it will do the operation. Okay, we'll see the programs in Xilinx Vivado. Same inputs I give it. Okay, so what is this this program I'm copying? One second, I'm copying and I'm pasting here. Okay, this is bitwise AND operation. Bitwise AND operation means A equal to what? A equal to A equal to, one second, 1 0 1 0 1 5, no, 5 means what? It will take as 1 0 1 0, and B equal to what? 1 1 1, and C equal to, tell me, x x x. Okay, so that means here y equal to x equal to A bitwise and B. Okay, A and B. Okay, A and B means what? 1 0 1 1 1 1. Okay, so you need to do bitwise and operation. Okay, so this is 1 0 and 1. Okay, you will get x equal to this one. Okay, similarly B, y equal to what? Y equal to A bitwise and of C. Okay, what is and 1 0 1? C means x x x. Okay, what you will get? 1 and 0 is 0, 1 and 1 is 1. Here you will get x, here you will get x, here you will get 0. Okay, x 0 x you will get. Okay, similarly B, so z equal to what? B bitwise and of 0. Okay, so bitwise and of 0 means B equal to 1 1 1 and 0 0 0. Okay, so what you will get? This is AND operation, so 0 0 0 you will get. Okay, so like this you can analyze the bitwise OR also. Okay, bitwise OR also you can analyze, bitwise XOR also. Okay, bitwise XNOR also you can analyze. Bitwise it will do. Okay, just I will show in the Vivado tool, Xilinx Vivado tool, you see here. So this is the same program I wrote. Okay, bitwise AND operator. So whatever the code you are simulating, just you need to set as stop, bitwise AND operator. Okay, so run simulation, run behavioral simulation, run behavioral simulation. See here, the value of x is what? 1 0 1 you got. The value of y is x 0 x you got. Okay, value of z is 0 0 you got. Okay, this is bitwise AND operator. Suppose if it is bitwise OR operator, see here, same values I took. Bitwise OR operator. Where is my bitwise OR operator? One second. Bitwise OR operator. Okay, this one is bitwise OR operator. Okay, only symbol is changed. All values are same only. Set as stop, and run the simulation, run behavioral simulation. So you got that means for OR operator x is what? 1 1 1 and y is 1 x 1 and z is 1 1 triple 1. Okay, this is bitwise OR operator. Similarly, you can see for bitwise XOR also. Okay, bitwise XOR. This is bitwise XOR. Okay, just set as stop, and run the elaborate. One second, not elaborated again. Cancel it. Run the simulation. run behavioral simulation. Run behavioral simulation. Yeah, see here. So the value of x is 0 1 0, value of y is x x x, z is 1 1 triple 1 will get. Okay, this is about the bitwise operators. Any doubts or any queries in this bitwise operators? Shall I move forward?
Yes, sir.
Okay, this is bitwise operator. Okay, and next you see the what we call bitwise operator is completed. No, we seen with the program also. And next is reduction operator. So what is this reduction operator? uh, so you asked that doubt, no, what is the difference between this bitwise and reduction operator? So in the reduction operator, so you have like so bitwise reduction and reduction or like that over there. Okay, suppose reduction and means suppose here you will represent x equal to and of a, x equal to and of a. Let us take a equal to what, 101. Okay, so this is a unary operator, that means what, only one operand will be there and it will do the and operation of each and every bit. So 1 and 0 0 0 and 1 1 0. Okay, at last you will get a equal to 0. Okay, so this is a reduction and operator. Similarly NAND is there. So NAND means what, so x equal to this not of, this is nothing but reduction operator. Okay, not of and of a. Okay, not of and of a means what, first it will do the and operation, and operation output you know. Okay, so that means not of 0, so here you will get x equal to what, 1. Okay, reduction NAND. Okay, and similarly reduction OR. Reduction OR means what, x equal to this one, this symbol and a. Okay, so that means 1 or 0 or 1. Okay, so 1 or 0 1, 0 or 1 1, so you are getting x equal to 1. Okay, x equal to 1 you will get. Reduction NOR means what, reduction NOR means this will be represented like this. So the not of R of a, not of R of a means what, anyway you got R, no, so that means that is not of 1 means you will get x equal to what, x equal to 0, x equal to 0. Okay, similarly you have reduction XOR. Reduction XOR, so reduction XOR means the symbol will be like this. So here x equal to cap of a, x equal to cap of a. So a equal to what you took, 101, no, 3 bit. So 1 XOR 0 XOR 1, so this is equal to, you are getting 0. So a equal to what, 0 you are getting. Okay, and reduction XNOR. Reduction XNOR. Reduction XNOR means here x equal to, let us take XNOR of a. Okay, XNOR of a means what, anyway you got XR, no, so complement of 0, this is equal to a equal to 1, so x equal to 1 you get. Okay, not of 0 is 1, no, so that means complement of x you are getting 1. Okay, so this is the reduction operator. Okay, this is about the reduction operator. Next you have the concatenation operator. So what is meant by concatenation? Concatenation is nothing but combining. Concatenation operator, concatenation operator is nothing but combining. Okay, so combining is nothing but, suppose if you take a equal to 101 and b equal to 011 and combining means so here you can take y equal to what, you need to include with flower bracket, this is nothing but a comma b, a comma b. So after this you will get y equal to what, 101 011. Okay, combining. Suppose if you are making x equal to b comma a, b comma a, so x equal to what, you will get b is 011 and a is 101. Okay, combine. Okay, and one more we see, replication operator. Replication or we can call as concatenation. Concatenation by using repetition. Okay, repetition using concatenation. Okay, so this is repetition using concatenation. Repetition using concatenation. Okay, so how you write the repetition using concatenation? Suppose you take x equal to let us take 101. Okay, x equal to what, x or a equal to, you take same value, a equal to what, 101. Okay, you are writing x equal to uh, 2 times flower bracket x a, 2 times flower bracket a. Okay, so that means x equal to what, 101 and 101, like this you can represent. Okay, suppose in the concatenation, suppose y equal to 1010 is there, and I want to like I want to write x equal to b of 0 comma a. Okay, this is the index value 0 1 2 3 4 and 5. So I can access like this also, x equal to what, I can access the 0th bit of y. Okay, that is let us take this is b of, no, okay, let us take this b, this is b. Okay, b of 0. Okay, b of 0 means what, I can access the index value also. So b of 0 is 1, what is a value, 101. Okay, after that, after concatenation I will get this value 1101, like this I will get. Okay, so this is the concatenation operator. Okay, and next is you have shift operators. Okay, what are the shift operators? Shift operators again divided into two types. Shift operators, in the shift operators you have logical shift left, logical shift and arithmetic shift. Arithmetic shift. Okay, arithmetic shift. Again in the logical shift there are two types, one is left shift and right shift. Okay, so again these are divided into two types, left shift and next right shift. Okay, in arithmetic shift also again these are divided into left shift and next right shift. Okay, so left shift means it is represented like this. Logical left shift means the symbol is this one, logical right shift means symbol is this one. Okay, and arithmetic left shift means the symbol will be 3 less than. Okay, right shift means 3 greater than. Arithmetic shift, right shift. Okay, so like left shift means suppose if you take some value, suppose y equal to 101, y equal to 101. Suppose if I do logical left shift by one position. Okay, one, what happens, so 101 is there, no, so this will be shifted. Okay, this will be gone, and this will come to this position, and this will be come to this position. Whatever the vacant position is there, that will be loaded with 0. Okay, this is logical left shift. Okay, suppose logical right shift you take. Okay, logical right shift, this symbol. Okay, one second. Yeah, logical right shift means I will tell you. Logical right shift means you take same number 101. Okay, 101 means what, so this will be gone. Okay, this will come to this position, and this will come to this position, and whatever the vacant position is there, that will be loaded with the 0. Okay, like this you can do the logical right shift. Suppose I want to shift 2 times, I will use this. How many number of shifts you want to do, that number you need to include. Okay, so 2 times means so 101 is my number. First shift I got which number, 010. Second shift this will go, this will come here, and this will come here, and this so vacant position is loaded with 0. Okay, so this is about the logical shift, logical left shift and right shift. Okay, and arithmetic shift if you take, so arithmetic shift is so arithmetic logical, so again there are left shift and right shift, no, so left shift is same as logical left shift only. Okay, logical left shift. Okay, that means you take same value, so a equal to 101, logical left shift by, sorry, arithmetic, this is arithmetic left arithmetic left shift by 1 means so it will do this operation. That means here this will be shifted. Okay, so this will go, and this will be come here, and this will come here, and whatever the vacant position is there, that will be loaded with 0. Okay, so that means So normal shift operation will be done in the unsigned shift operation, but mainly this arithmetic shift mainly we are using in the signed numbers. Okay, so normally we will do with signed numbers. Let us take suppose m equal to 11101. Okay, I told you the signed numbers. No, signed numbers means what the MSB decide the given number is positive or negative. If MSB is 1, given number is positive, and MSB is 0, the given number is negative. Okay, so that means when I am doing arithmetic right shift, it will hold this MSB. Okay, it will hold this MSB, and again it will shift. This will become to 1, this will comes to here, and this will comes to here. Okay, the change will come in the right shift. What is the difference between the logical and arithmetic means the change will come. So in the logical normally it will shift, but it will hold the MSB bit. It will hold the MSB bit.
Sir, it will only hold if it is negative, or even if it is positive, it will hold.
Positive also it will hold. Positive also it will hold. Positive means the change will come in the right shift only. Suppose if you take the positive number 010, okay, I'm writing like arithmetic right shift. So how it will do? First it will hold the MSB bit. Okay, so this will hold the MSB bit, and after that it will shift. So this 0 will be shifted, and this 1 will be shifted, and this 0 will come here like this. Okay, the change will come in the right shift only. The change will come in the right shift only. Okay, left shift both are same only. Understood?
Okay, sir.
Okay, next you see relational operators. Relational operators. What are these relational operators? Relational operators are, you have the outputs can be three types. It can be true condition, that is 1. It can be false condition, that is 0. It can be unknown condition. Unknown condition. What is unknown condition? This is x. X is nothing but unknown condition. So let us take you have a equal to 3 and b equal to 4. Okay, a equal to 3, or you take a equal to 4 and b equal to 3. Okay, b equal to 3. Case 1. Case 1. Okay, suppose a is greater than b. What is the output? 4 is greater than 3. True or false? True. Output is what?
True.
1.
1.
Okay, a is less than b. Output is false, 0. Okay, a is greater than or equal to b. What is the output? 1. Why? Because it is satisfying. No, only one condition is satisfying. A is greater than b is satisfying. So that means it will do that. It will throw the true condition only. Okay. A is less than or equal to b. So what is the output? Output is 0.
0.
Output is 0. Okay. And next we'll see the case 2. Case 2. Let us take a equal to 3 tick binary 0 0 x. Okay, b equal to 3 tick binary 1x0. 1x0. Okay, now which one will satisfy? Tell me. What is the output? Suppose I am calculating a greater than b. What is the output? 0 0 x means what? What are the conditions? What are the values? 0 0 0, and what is this? 0 0 1. Okay, 1 x 0. So that means 1 0 0 1 1 0. Okay, so that means so here, so that means compiler can't decide whether it is true or false. The output is what? X. Output is x. In this case the output is x. Why? Because you have x in this. Okay, you have x in this, that's why the compiler will throw that is x only. Okay, so this is a relational operator. And next we have equality operator. So what are these equality operator? We'll see. Equality operator, you have two types are there. Equality operator. What are these equality operator? So you have one is logical equality. Logical equality. Logical equality. So you have these symbols. This is nothing but equality and not equal. This is not equal, not equality, not equality. Okay, and next you have case equality. Case equality. So case equality, you have equality means three equals are there. Three equals are there, and not equal means not followed by two equals are there. Okay, this is equality, case equality, and this is case not equality, not equality. Okay, so that we'll see. Okay, what is this? We'll see. Suppose, so let us take one example. So here a equal to 3 tick binary x xx1. Okay, b equal to 3 tick binary. Okay, 0 1 1. Okay, I am calculating what a logical not equality of b. A logical not equality of b. Okay, so that means I am checking whether it is equal to or not equal to. Okay, equal to or not equal to. Okay, so that means here you will get the output x only. Okay, you will get the output x only. Why? Because in logical equality, so in logical equality, if condition is satisfying, you will getting, so there are three values are there: false condition, true condition, and unknown condition. Okay, so in logical equality, if output becomes x unknown, if any if any if any one of the bit is x, if any one of the bit is x. Okay, in the input if any one of the bit is x, it will give the output as what? X only. Okay, x only. So if condition is not satisfying, this is x only. Suppose if it is case equality, suppose coming to the case equality, so I am checking, let us take a equal to 3 tick binary 101 and b equal to 3 tick binary x01. Okay, x01. I am checking for case not equality. Case not equality. Okay, what is the output I am getting? I am checking. Okay, what is the output? So in terms of case equality, it will compare with the don't care also. So that is 101 and x01. Okay, it will compare each and every bit. So this is this is equal, this is 1 is equal to 1, and this is 1 is equal to 1. It will compare 1 with don't care. So 1 with don't care means both are not equal, no? So both are not equal means this total value is not equal. So the condition is satisfying. The output becomes what? 1. Okay, that is the difference between logical equality and case equality. In logical equality, any one of the input is x, so that means it will throw like output will be x only. Either it may be logical equality or not equality. But in terms of case equality, it will compare each and every bit with this x only. Okay, so that is the logical equality and case equality. And next
Sir, now the output should be zero, na?
which one?
Like after comparing those bits, one when it is compared with x, it is not equal.
I am
So if it
checking
is
for
not
not equality, no?
okay, okay,
I am checking
okay,
for not equality. If it is equality, output is equal to 0. But condition, what is my condition? Whether I am
not
checking not equality. Not equality means these both are not equal, no?
okay,
Okay. So if condition is satisfying, I will get the true condition. If condition is not satisfying, I will get the false condition. Okay.
okay.
Okay. And coming to the ternary operator. So what is ternary operator? So this is a conditional operator. Conditional operator. Conditional operator or we can call as ternary operator. Ternary operator. Okay, so what is this ternary operator? So see here, suppose the syntax will be like this. The syntax will be, so ternary operator means three operands are there. Three operands will be there. Okay, three operands will be there. So the syntax is like this. Syntax is condition, expression, condition, expression, question mark, true expression, colon, false expression, colon, false expression. Okay, so this is mainly used when you are like in digital. We can write by ternary operator. In digital, you already seen 2 cross 1 marks, no? You already seen 2 cross 1 marks. Okay, so you can write the logic with one line in ternary operator. Okay, it is like if else statement only. Let us take the inputs are what, a and b, and the selection line is what, yes, and output is y. Okay, so for this I am writing the ternary operator. How I can write the ternary operator? That means y equal to yes. Okay, that means what, if y equal to 1, which one will be connected with, sorry, one second, y equal to yes, that means when s equal to 1, which one will be connected?
B.
B. So that means B is connected. B is connected to A. Or otherwise, so that means y equal to yes, so B, or otherwise A. Otherwise A. So within one condition, I wrote the logic for 2 cross 1 marks. So that means if s equal to 1, y is connected to what, B. Okay, or else y equal to what, A. Okay, so this is the operation of ternary operator. Okay, understood? Did you understood? These are about the
Yes.
operators. Okay, so once you check, we completed, we already covered concatenation, replication, unary operator. Okay, unary operator means those the addition operators only. Arithmetic, modulus, I think these you know. Okay, these are basic mathematical. Relational operator, greater than or equal to, less than or equal to, logical negation, logical and, logical or, logical equality, logical inequality, case equality, case inequality, bitwise negation, and bitwise inclusive or, bitwise exclusive or, bitwise equivalency, that is bitwise XOR, reduction and, reduction or, reduction XOR, reduction XNOR, and relational operators, those logic shift operators, logical shift left, logical shift right, arithmetic shift left, arithmetic shift right, conditional or ternary operators. All operators we covered or not? Just see and tell me. Waiting for your response. Hello.
Done, sir. Have covered.
Okay, all are covered, no? Anyone is missing? Anything is missing? I think no need to say this one. This is mathematical operators. Okay, no need to explain. These are nothing but remainder and this addition, subtraction, multiplication, and quotient. This you know. Okay, no need to explain. Just you need to remember these operators. Remaining operators, all operators have we covered. All these operators we covered. Okay. So tomorrow we'll start with data types. Okay. So anyone have any
Okay,
doubts or
sir.
queries?
No, sir.
Okay. Okay, then we'll meet tomorrow. Thank you.
Thank you, sir.